In early 2025, a series of astronomical observations revealed an object of unknown origin entering the inner solar system. Initially resembling the interstellar object Oumuamua, which passed through in 2017, this new body exhibited behavior that sharply diverged from any known natural mechanics. It did not follow a gravitationally determined trajectory. Instead, it appeared to decelerate, shift its course deliberately, and eventually stabilize in geosynchronous orbit directly above Earth's magnetic equator. The object was later designated as Oumuamua, a nod to its mysterious predecessor, yet clearly something categorically different. Unlike the original Oumuamua, which traveled on a hyperbolic trajectory and exited the solar system without deceleration or maneuvering, Oumuamua displayed signs of controlled motion. Multiple independent observatories, including those in Mauna Kea, La Silla, and Siding Spring, confirmed that as the object approached Earth's vicinity, its velocity decreased significantly and its path began to bend in ways uncharacteristic of purely gravitational interaction. After entering Earth's orbital region, the object settled into a stationary position in Earth's sky, fixed over the same longitudinal position of the equator, similar to artificial communication satellites. Shortly before this orbital stabilization, the James Webb Space Telescope, JWST, recorded a brief yet highly structured electromagnetic pulse originating from the object. The emission included a sequence of prime numbers, non-repeating, non-random integers often proposed in theoretical scenarios as a logical form of communication between intelligent species. The signal, though brief, was clear and unmistakably directed toward Earth's magnetosphere. While some suggested natural phenomena such as pulsars or magnetars as possible sources, spectral analysis and directional data ruled out known stellar sources. The signal bore none of the broad-spectrum noise or irregular decay typically seen in natural emissions. Following the pulse event, NASA's JWST live feed was quietly taken offline. Archival data linked to the object's observation were removed or marked inaccessible. While no official reason was given, space science communities immediately noticed the blackout. Independent institutions, including the South African Astronomical Observatory and the European Southern Observatory, confirmed the object's position and trajectory independently using radio and infrared telescopes. Although they lacked full access to JWST's infrared and ultraviolet capabilities, they verified the unusual behavior of the object and detected irregular emissions not consistent with asteroids, comets, or space debris. Attempts to observe Oumuamua in detail using conventional telescopic methods were met with inexplicable complications. Observatories reported that optical systems focusing on the object experienced momentary lens misalignments or unexplained thermal blooming, rendering high-resolution imaging unreliable. Long-exposure images suffered from unexplained pixel drift, as if the spatial coordinates of the object were subtly fluctuating or interacting with the observing equipment. At least 2 observatories noted temporary desynchronization of their telescope star tracking systems, which rely on precise stellar positioning. These anomalies pointed toward a possible interference with local spacetime metrics, suggesting not just a passive object, but one potentially generating or altering its surrounding field. Thermal imaging revealed further peculiarities. Despite being exposed to varying intensities of solar radiation during orbit, the object maintained an unnaturally stable temperature profile. No significant cooling or heating fluctuations were detected, implying some form of internal thermal regulation, or possibly an active energy redistribution system, technology far beyond human engineering. The surface characteristics, inferred from polarized reflectivity data, suggested that Oumuamua was not composed of rock or metal but of a material capable of dynamically altering its reflectivity spectrum. Possibly some kind of adaptive surface or cloaking matrix designed to minimize detection or energy absorption. On April 7, 2025, an unexplained global magnetic pulse was registered by CERN's magnetometer array, normally used to monitor particle beam activity in the Large Hadron Collider. This pulse coincided precisely with Earth's natural Schumann resonance, the extremely low-frequency waveforms that result from the planet's electromagnetic cavity. The signal lasted approximately 0.72 seconds and matched the mathematical periodicity found in the earlier emission from Oumuamua. Simultaneously, several GPS satellites reported fractional timing errors and momentary telemetry disruptions. Initially classified as a probable geomagnetic disturbance, the anomaly was re-evaluated when NOAA and ESA confirmed the absence of solar flare activity or terrestrial sources. This magnetic signature appeared globally synchronized, and yet bore no known electromagnetic precursor. Analysts noted its harmonic coherence aligned with the prime number sequences previously transmitted, suggesting deliberate coordination between the object and Earth's natural magnetic infrastructure. In a development that deepened the mystery, the Deep Space Network unexpectedly received a data burst from Voyager 1, humanity's farthest traveled spacecraft, currently located over 24 billion kilometers from Earth. The signal did not conform to Voyager's legacy communication protocols. Instead, it contained complex harmonic modulations and multi-tiered compression formats inconsistent with the spacecraft's onboard transmitter capabilities. Engineers confirmed Voyager lacked both the memory and processing power to have initiated such a transmission autonomously. This event, while brief, revealed that Oumuamua, or the intelligence behind it, could not only interact with Earth's magnetic systems, but potentially manipulate or interface with human technology from vast interstellar distances. Embedded within the Voyager signal were packet structures resembling instruction sets or layered data blueprints. Although no full decryption has been achieved, pattern recognition software identified recursive logic chains indicative of artificial syntax. Astrophysicist Brian Cox, in a statement to the Royal Astronomical Society, proposed that Oumuamua may be part of a distributed observation system, an intelligent network seeded through the galaxy by a civilization advanced enough to detect emerging technological societies. He theorized that such systems could remain dormant until triggered by specific milestones: quantum entanglement experiments, subspace communication, or high-energy particle acceleration. Earth, he suggested, may have finally crossed one or more of these thresholds, activating a passive observational node now turned active. Support for this idea came from renewed examination of data from 2017's original Oumuamua flyby. Several researchers, including Avi Loeb from Harvard, have long speculated that object's anomalous acceleration and lack of cometary tail indicated non-natural propulsion. With the appearance of Oumuamua, displaying similar shape but drastically advanced behavior, the argument gained renewed credibility. Since its arrival, Oumuamua has remained in its geosynchronous orbit. It has not responded to directed communication attempts. Ground-based laser pulses, narrowband radio transmissions, and high data rate optical signals aimed at its position have produced no measurable reply. However, subtle shifts in its energy emissions, particularly in the infrared band, suggest that it continues to monitor and perhaps react in non-communicative ways. Satellite coverage of the region beneath its orbit has also reported minor signal interference consistent with high-frequency energy scattering, although the source remains unconfirmed. The object has not exhibited aggression nor attempted any form of physical contact. Its presence, however, has led to increased military, scientific, and diplomatic coordination among spacefaring nations. The United Nations Office for Outer Space Affairs issued a low-profile advisory requesting observatories worldwide to standardize data reporting formats and avoid speculative press releases. Meanwhile, unverified reports claim that certain high-altitude reconnaissance flights over the Pacific equatorial belt have observed electromagnetic disturbances consistent with low-orbit gravitational lensing. As of July 2025, Oumuamua remains in position, stationary, silent, and unresponsive. Yet its continued presence challenges our most fundamental assumptions about the cosmos. Is it here as an observer? A messenger? A system diagnostic tool for something far greater and more complex than we can comprehend? We do not yet know. But one thing has become undeniable. We are not alone in our awareness of ourselves. Something else is watching. It may have been watching for a long time. And now, it has made itself known.